I'm Joanna Williams and I'm an Associate Professor at the University of Otago. My lab's current focus is on preventing Alzheimer's disease. This is a devastating disease, and despite decades of research, we have no cure or even a therapy which can significantly slow the progression of the disease. Why is this? Alzheimer's is a slowly developing neurodegenerative disease which results in loss of cells in vulnerable regions of the brain. And it seems that even when patients show the earliest symptoms, the pathological processes are too advanced for therapies to be effective. The key to this problem is early detection, which will allow early intervention in the disease. In Aotearoa, New Zealand, we have a particular responsibility to the tangata whenua, and our research focused on understanding how memories are formed in the brain is particularly relevant to Maori, as theirs is an oral history, and if this line is broken, so is the connection to the past. In my lab, we study a protein called SAPA, secreted amyloid precursor protein alpha, as a potential therapeutic, and alongside this, we are monitoring changes in microRNA patterns within blood plasma as early diagnostic markers of Alzheimer's disease. Through collaboration with the Australian Imaging Biomarker and Lifestyle Group, the ABLE group, we have been able to show that specific microRNA change before symptom onset, and they also change as the disease progresses. In this work, we have used custom-designed TaqMan microfluidic arrays to really robustly measure the levels of microRNA in plasma. They've been there right from the beginning, even lending us a PCR instrument to carry out our first studies. And we're really grateful for that. We are really hopeful that the work that we have done will form the basis of an easily administered early diagnostic test, which will allow people at risk of dementia to be identified early so that therapies can be given early. We want to give hope in the face of this ever-increasing disease. The biggest challenges that I face is securing funding for our work. Longitudinal studies are expensive and time-consuming. This can be demoralizing, but I am constantly inspired by the dedication of those carrying out the work and the excitement of the new students who join our lab. It makes it all worthwhile when you see your students succeed and develop into independent, passionate young scientists. What work is there left to do? I feel the most important work is to identify people at risk of developing Alzheimer's disease before changes in the brain become too advanced for any therapy to stem the cascade of the disease. Alongside this, it is imperative that we develop therapies that can actually make a difference. There's much hope in this area because we may already have effective therapies that have to date been delivered at the wrong stage of this slowly developing disease. My hopes for the future are that early detection and early intervention in Alzheimer's disease will create an environment where elderly people can expect to enjoy time with their grandchildren, passing on their memories, keeping their whakapapa strong.